Hello and welcome again to As We May Think. This is the second part of my series on web components. Specifically, this one is all about web components in their most basic form. You saw one of those briefly in the last video. It was as minimal as you can get. It was just 9 lines long. A couple of those were just blank lines. And it was a component that went and got one of its attributes, inserted it into a string. That string became its HTML. That was it. But web components can do, obviously, a lot more than that. They can basically do anything that a normal element in a web page can do. They can do vast amounts of HTML. They can pull elements from inside of themselves and make use of them to become part of the overall structure of the HTML. They can react to changes to their attributes as well as changes to their properties. They can tell when they are added to the page or removed from the page. This is a really good article about custom elements, which is just the portion of web components that deals with creating custom elements. The part where, for example, in the last one where I said example element equals this class, that's what this is about. I recommend you read it, but a lot of what's covered in here is also stuff I'm going to be covering today. I don't think there's a lot about the Shadow DOM in here other than the basics of making sure that you have Shadow DOM turned on if you want to use it. It does cover the most basic of things that have to do with how a custom element can react to the world around it, though. You can have a constructor in one. You saw the connected callback in the last example. There's also a corresponding disconnected callback, which is called every time your element gets removed from the page, whether somebody did it by changing the HTML in the page via the dev tools, or whether it happened because of JavaScript changes or whatever. However it happened, you'll get a disconnected callback that you can use if you needed to, for example, cancel a call to the server or cancel a timer or whatever you needed to do. There's also the attribute changed callback, which is all about telling you whenever some of your attributes have altered. So if you've got some DOM attributes, like in the previous example was name, if that were to change, the attribute change callback would get called. But that's only true if you've listed that attribute in an observed attributes property. If it's not listed there, you don't get a callback about it. And the reasoning behind that is if you were to make a bunch of changes, for example, to class or style or the ARIA tags, any of those kinds of things, you might not necessarily want to receive those kinds of changes. So not every single attribute that's tied to your elements is automatically going to notify you. It's up to you to decide which ones you're interested in getting notified about. And this finally, I've never had occasion to use this, but there's also an adopted callback which has to do with something when it's been being moved from one document to another. I haven't really needed that myself, but it's available. So this fairly minimal set of stuff is really what you're going to build on top of if you're going to try and do vanilla JavaScript components. Now, with that said, it's hard. It's hard in the sense that you will find yourself repeating a lot of stuff. There'll be a lot of boilerplate, and you will find yourself very quickly writing little library functions to do a bunch of stuff. So when I set out on learning web components a long time ago, and in particular some of the different libraries that were out there, and also just raw web components at their most base level, I decided I needed a project. And so my project for this case was a library called Piety, which sounds like deity. I'm not sure why he didn't go with piety, because that would have been a natural pun for pie charts, but whatever. It's a nifty little library from a fellow. I like it, but it's got some stuff that I don't love about it. For example, it requires jQuery. I don't really need jQuery normally in my apps, so I don't care about that. And also, it used it apparently, I think, wrote all of its own SVG internally, and I thought, hey, this is another case where I could learn a little more D3 stuff because I like D3.js, which is a really neat library for doing different kinds of charting and visualizations. And so I thought, let's combine all this stuff into one. Let's get rid of the jQuery dependency. Let's add D3. Let's build a new version of these as components. As you can see, when in these examples, they're just sticking in spans, and then those spans have the numbers inside them, and the class tells it what kind of component it is, effectively, what kind of graph it'll be. And then some other JavaScript has to come along later and connect the two up. But if you've ever done this kind of code, you know it can be very easily broken if another piece of code comes along and adds a pi later, for example. There isn't necessarily anything to connect these two. You would have to be sure to rerun this again so that it would all work. With custom elements and web components, that's not necessary. You're always going to get called because the browser guarantees you that you are. So there are 4 different kinds of graphs that are just kind of little nifty inline graphs that Peyote covers. I only built 3 of these. If you want to go in and build the line chart one yourself based on my code, I've already got it partially started, so I'm going to leave that one as an exercise to the reader, or viewer in this case. But anyway, the other 3 out of the 4 are covered, and you'll even get to see some of these data attributes in action in my examples. So let's do that next. Let's come over here and look at the stories that I wrote. So the stories are going to look really familiar because they're going to look just like the ones you saw a moment ago, except that they're going to be components instead. So instead of having a span, I actually have a web component and named wc-pi. I'm going to rename these later probably to vanilla-pi for all the vanilla components versus the lit element versions of them. But for the moment, we'll just call this is what I already had. So we're going to go with wc-pi, wc donut, wc line, wc bar. Those are the examples. And so these are the little chunks of components being used with attributes for the various kinds of graphs. Let's come back over here and let's look at the storybook with that all filled out. So here are the pie charts, the donut charts, the line charts, not filled in, the bar charts, and finally the various attributes being used. You'll notice mine work just like his do, only I'm using D3 and web components to do my work. So what do the web components for those look like? Well, I tried to do mine absolutely white room. I never looked at his source code at all. I looked at his output, and I looked at also quite a bit of the D3 stuff because I was trying to, learn how to do the same things in D3. So here are my versions of the components. They may not produce under every circumstance exactly the same code because obviously I did not dig into his code to see how he did it. I wanted to see if I could do mine completely independently. My version, I found that there was a lot of common code between each of these different classes. I didn't want a toy example. That's why I actually tried ripping off and rebuilding the examples from, I believe Ben Pickles is his name. So I thought it would be neat to do something that was hard enough that it was difficult. And I couldn't get by with just the hello world kind of nonsense. I had to build something more sophisticated. So here's an example down here. Here's the pi element. It extends the base element you saw above. And the base element is actually the one that extends HTML element. So you can, if you need to, put some code into a shared class and then have other classes make use of that shared code. So that's the first thing to know about custom elements and web components. It's class-based. That's how it works. So you get to use the power of classes. You can have constructors, you can have parents and children, and they can make use of each other's code and see each other's variables and do all kinds of cool stuff there. So that's why you see a shared base element that I use for a bunch of stuff. Now here is one particular one. This is the pi element. It's got some initial values that it sets up. Like there's a default radius for it. Then there are some, you may remember I mentioned that there were observed attributes. Those are the only ones that get watched for changes. So if any of these attributes gets changed on one of my elements, I get a notification about it. That actually gets caught in the parent element. We'll go back up to that code in a minute. And then there are a whole bunch of properties. So the properties represent the various values that the class has on it. So anytime you think of a component, remember both that it has properties, which are various values, and then it has attributes. And the attributes, when you change them, you can get those reflected down onto the properties, and the properties can be what you actually use to draw things or react to things. Also, they're pretty much the only way you can pass in certain kinds of data. If I need to put a whole array of objects into a component, I cannot do that from attributes, right? Properties are how I do that instead. So that's what we're doing here. So these are the various properties that this particular component makes use of. And naturally enough, most of them correspond to different attributes which can be set from outside. One thing that's a little different about Ben's components is that he puts all of the data in as a comma-separated set of values inside the body of the component itself. I imitated that because I thought it would be really neat to see how that would work in a web component, and I was able to make it work just fine. So everything that he did, I was able to do as well. Here are all the properties, getting them and setting them. And then here is the code which is actually using SVG to render the pie, for example, using D3. The donut is basically based on the pie. It's exactly the same, except that there's an inner radius and an outer radius. So I wrote the pie to allow for an inner radius. Its inner radius is always 0. In the donut version, the inner radius can actually be set and has a value. Likewise, there's probably a commonality between the line element and the bar element as well. I haven't gone through, like I said, I didn't actually build out the line element all the way, so I cannot say for sure that there's an overlap, but all of these had some significant overlap. Let's go back up to the top and you can see some of the repeated code. Here's where I'm actually registering all of these different custom elements. Here's the name, and then here are the classes that are making them actually work. Let's come back up here to the very top, and we will discuss, these are the default options. They're being set in the constructor. And there's some, I found myself writing code to do things like connect attributes to properties. So I know that an attribute changed. I get notified of that by the web component infrastructure. When that happens, I know that that needs to get reflected back onto a property. And I may need to also convert the value itself. For example, it's always a string when it's an attribute, right? But some of those I need to become numbers so that they get assigned to a property which is always going to be a number. Sometimes in JavaScript it might get assigned a number, but the attribute comes in as a string, and the two have to get translated correctly to always be a number when it goes onto the property. And sometimes when I change a property, I want its change to be reflected up onto the attribute. A classic example of that is the idea of something that is disabled. If I disable a given component, I might set a property that says disabled, and then I want that to reflect in a disabled property suddenly appearing on that component in the HTML or the DOM. Why? Because that might affect other styling code that could make use of the disabled attribute to correctly style that or style something beneath it. Ignoring the shadow DOM for the moment. But that's important, and sometimes that's why you want a change of a property to reflect back up onto an attribute, but you end up having to write all that code yourself. All of that conversion code of attributes into property values of the right type, all of that reflection. Whenever you want to do it, and you don't always want to do it, like I mentioned a minute ago, if I'm setting a big array of objects onto a component, I don't want that to suddenly get reflected back into an attribute on the page, some big JSON string appear on the page that represents all the stuff that got set onto a property. So that's the one where I don't want it to reflect. All of this code you end up writing for yourself, and I don't recommend that you do it. I wanted to show you this. I wanted to make these examples available to you because in the next video, what I want to do is I want to show why it's so much easier to write this sort of code with code that already handles all of those nitty-gritty bits for you. When you compare this to LitElement, what you'll see is that LitElement says, okay, I am going to assume by default, unless you tell me otherwise, that you want Shadow DOM on. I want you to tell me about all of the attributes that you've got, and if you want them converted into a particular type when I receive a string on one of them, let me know about that. Likewise, if you want to change a property and then have that reflect back out into the attributes, let me know about it. And so you can simply set a set of values and have those things happen for you automatically. And you can concentrate only on the parts that interest you, which are things like drawing things correctly or interacting with the user when they click on parts of your user interface, or going and getting the data that you need to get, manipulating it however you need to manipulate it, and render it. So what you're going to see in the next video is the same thing as this, only a lot shorter, and I think a lot easier to write. I hope you enjoyed this. Thank you so much for watching. Again, the source code will be referred to. There's a repo that will be linked to at the bottom in the show notes. And please like, subscribe, tell all your friends about the show, and I hope you come back again. Thank you so much for watching. Bye-bye.